Yes, class. Am I audible to all of you?
Yes, ma'am.
Sarah, Yasir. Sarah, in the last class you were there. What about the classes before that? You were absent in between.
Yeah, in between I'm.
Just take the video lectures, at least have the backup classes from there, right? So that you don't miss one with them. All right. So work energy in power, you are there in the starting. No? Okay.
Yes, ma'am.
The last class we started with the concept of work done. So work done's formula was basically force dot product of force and displacement. F is cos theta. This we had seen. It's a scalar quantity. SI unit is joule. This and CGS unit is erg. So basic formula apart from this we have seen. One part that is left from here. And yes, if you have a variable force, that F dot dx, we apply. Did you all attempt the after class assessment in the last class on Tuesday? Yes or no?
Yes, ma'am.
Yes,
Okay. Harsha, did you receive the solutions?
Yes, ma'am.
Okay, Alia is also confused. Okay, good then. I have not actually seen your scores. I'll see today. And you have your test tomorrow also. So tomorrow only circular motion is coming. Laws of motion, the entire lesson is not coming. Just prepare circular motion part. Circular motion means the entire circular motion. That angular displacement, angular acceleration, that part also, bending of road, bending of cyclists, the entire circular motion part will come. Yes, one thing that was left in the last class from the topic work done was graphical methods. You will be having questions which will involve a particular graph from which you have to study it and give the value of work done, similar to the value which we give through which we give by the formula. So we use the formula Fs cos theta. Suppose you are given a graph, how will you calculate? Just remember one thing. Whenever two quantities are getting divided in division, if two quantities are getting divided, then you calculate its slope using tan theta. All right. If two quantities are getting multiplied, then the quantity is given by area of the slope. So here also, what is our formula? Work done is equal to force multiplied by multiplied to displacement. So it is multiplication. It means work done is given by area under the graph. Work done is given by area under the graph. If it is above the axis, means all the coordinates are positive. You will take it as plus, positive sign will be mentioned. If it is below the graph, it is below your axis, you will consider it as a negative sign. Everything is written on the board. You will get sufficient time to note it down. First, let us see a question. So area above displacement axis is positive, area below the displacement axis is negative. Let's see this question. See, this is the shape given. Force and displacement both are mentioned. So what you will analyze by looking at force and displacement, that you have to find out work done. Now how to calculate work done? Work done is given by area under the graph. So our graph is not one single graph. You can see two shapes. Can you tell me the two shapes which you are able to identify from this graph? There are two shapes.
rectangle and triangle.
Rectangle and triangle. Very good, Sarah. A rectangle and a triangle. So when we talk about work done, it means the area of the rectangle plus area of triangle with the proper sign conventions. So area of rectangle, the length is 3 meters. See, this is given as 0, this is given as 2. And this part is given as 2. This will be 2 meters. See, this is 2, so this is also 2. And this along y-axis, so this is 3 meters. So again, area of a rectangle, that's length into breadth. This is area of the rectangle. Now, instead, What we'll do? Plus, let's put the sign plus, automatically we'll get it answer as minus. Why minus? Because this is below the displacement axis, right? This is below the axis. So we know we have to subtract it. So what we can do, let's put plus here according to the formula which we are following. Whatever quantities are mentioned, let's take them as per they are given. Means what is the area of a triangle? Half base into height. Base is 4, this is 2. So this separation is 2 meters, right? 4 minus 2 is 2. So half base into height. Height is this. So let's not take it 2. Let's take it as minus 2 as it is given. So automatically you will get a minus sign. 2 will get cancelled. So 3 into 2 is 6 minus 2. Answer is 4. That's it. This part was left from work. Your work done is completed. Work done is only this much in your syllabus. You just have to pay attention to this much part only in your work done. Now we'll be using work done in energy in rest of the part. Now we'll start with energy. So work, energy and power. Work done is completed. Energy will start. Before that, note down this graph. Graphs also questions are easy. You will be able to handle. Just remember these basic rules. Like you must have noticed whenever we find out the velocity, if displacement time graph is given, we never calculate their slope. We never calculate their area. We always calculate the slope. So why do we calculate the slope? Because they are getting divided. Distance getting divided by time. Displacement is getting divided by time. That's why we use tan theta and find out the graph. Had there been distance into time, or some quantity which is giving you distance into time, acceleration into time, velocity into time, that will be given through area of the graph. Simple. Area of trapezium, whether area of triangle, whether area of rectangle, area of square, whatever figure is being made by the graph. But whatever is the underlying area, just cover it and find out it. Note down this part, graphical method. See, the energy that you have in your system, this is divided into kinetic energy and potential energy, as I have mentioned on Tuesday also. So when we talk about just the term energy, no, means total energies in your system. Kinetic energy, potential energy, internal energy, gravitational energy, whatever energies are there in your system. Total energies. That is what we call as mechanical energy. All right. Now, when we use the term mechanical energy, specifically in your class 11, we talk about kinetic energy and potential energy. So when I'll ask you what is mechanical energy of the system, calculate kinetic energy, calculate potential energy, add them, that will be your mechanical energy. And in the last class, we have studied work done is scalar. Your energy is also scalar, your power is also scalar. So no need to worry about the Cartesian form, direction, no need to worry about the vector laws, right? For energies, what you will do, simply add it. Add, subtract, depending upon the sign. So mechanical energy is basically grouped into kinetic energy and potential energy. Now, kinetic energy is what? Whenever there is a change in the rest state of the body, that is, from rest, the body commences into motion. Now the energy that is being possessed, now the energy is being possessed means what? Now the work that is being done, all right, work done that occurs, work done which is occurring, gets stored in the form of energy, and that energy is known as kinetic energy. So kinetic energy comes with reference to motion. In the formula also of kinetic energy, you have velocity. Suppose, assume this is a velocity, or let's take here. A body is there, mass m is there, this is moving with velocity v, let's say. So kinetic energy will be half mv square. This is a very basic formula. I think in your lower classes also, before this lesson, you must have heard of this. Kinetic energy is half mv square as well. Half mv square is the formula, and since you are having velocity, see, if you put velocity as 0, kinetic energy will be 0. So kinetic energy will come into your system only when there will be a certain velocity. A very important theorem that you have is known as work energy theorem. Now we have studied work done. This is kinetic energy. Now how to relate these two? So work done, whatever work done is in your system, whatever is the work done, means to bring a body from its initial position to final position, apply a certain force, cover a certain displacement, entire work done theory which we have done on Tuesday, force into displacement, entire work done, that gets stored in the form of kinetic energy. So work energy theorem says what? Work energy theorem says that all the change in work done, this is equal to change in kinetic energy. And this is a very important statement because many places you will have to use this to find out velocity. Somewhere a random question will be given to you, energy and all, and velocity will be asked. How will you relate? You will relate it through work energy in theorem. That work done gets stored in the form of kinetic energy. So work done is equal to change in kinetic energy. Work done is equal to delta K. Delta Ke means the change. This means the change in kinetic energy. Now let us see a small derivation. This is a body, mass m is there. Let's say the body has started moving, acceleration has started accelerating also, velocity is also there. Let's say initial velocity, this is v1, the final velocity, this is v2. Certain displacement is also covered by the body. All right, the body is moving. Force is also applied to the body. Because of application of force, the body's velocity changes from v1 to v2. And because of application of force, there is acceleration in your system. Basics of motion in a straight line with what we have studied. Now, what is your work done? Work done is f dot dx, integrating it from x1 to x2. This is the formula which we have studied of work done, integrating it from x1 to x2. Since we are not taking displacement, we can take velocity also. Further, we can change velocity. We'll see that. Now, force will be what? Mass of the system is m. It's accelerating also with acceleration a. So F is equal to ma. This is the formula of force. Let's put it here. Let's put the formula of force in here. So this becomes MA dx, integrating it from x1 to x2. See, displacement we are not concerned with right now. I want to have velocity in my answer. I don't want to integrate it from x1 to x2. Displacement I don't want. That will give me work done only. I want in terms of velocity, because kinetic energy is related to velocity only. This derivation sometimes comes in your exam of 5 marks. All right, this is not very difficult to understand. This simple integration, but in many papers I've seen 5 marker section D it is given. So just have a look in the for your school exams. Acceleration. What is the formula of acceleration? Yes,
V
acceleration.
minus U by T.
V minus U by T. In terms of if the velocity we are finding at a particular instant, we differentiate it dv over dt. Let's substitute this value. So see, m dv over dt into dx, integrating it from. Now I have told you I wanted velocity v1 to v2. The problem that I couldn't change velocity is this dx. This is disturbing. If I am putting dx, I have to put the limits as x1 and x2. For v1 and v2, I have to have dv. Now I am having dv, so I can put the limits as v1 to v2. But what do I do with this dx? Can you notice this? Dx over dt. What is this? Dx over dt.
Velocity.
Velocity. Very good, Harsha. It's velocity. You have forgotten your first lesson. Motion in a straight line. Velocity is dx over dt. Acceleration is dv over dt. So if dx over dt is velocity, now dx problem is also removed. What is our formula now? mv dv, integrating it from v1 to v2. Now simple integration. Mass is constant. Let's bring it outside. v dv, v1 to v2. And this formula is valid. Half mv square is valid only when your mass is constant. If your mass is not constant, there is a different theory for that, which is not in your syllabus and you need not understand. Einstein's theories are also present. If mass is changing, mass is decreasing, mass is increasing, velocity changes, your constants, certain constants also get added. So don't worry about the mass. You will get mass constant in your syllabus. So mass is constant. Now coming to the integration, V has power 1. So how do we integrate it? That becomes power is 1. So this becomes 1 plus 1. And whatever I told you, whatever power now becomes, bring it in the denominator, right? Mass was already there. Now the limits were from V1 to V2. So this became M. This became by 2. This is V square, integrating it from V1 to V2. So yes, what is the final formula which we are integrating? What is the work done? Half mv2 square, upper limit first we will put, minus half mv1 square. And this work done gets stored in the form of kinetic energy. This gets stored in the form of kinetic energy. So your kinetic energy is this. All right. Now, what is half mv2 square minus half mv1 square? This is the change in kinetic energy, right? This is the change in kinetic energy. So your kinetic energy is half mv square. This means I am including the change as v square. Means if v1 is 0, this is half mv square only. But when we're talking about change in kinetic energy, this proves also, no, work done is equal to change in kinetic energy. So whenever the question is prove work energy theorem, this work energy theorem is very important. This I'll tell you. Work energy theorem in terms of calculation, numerical part also, for your theory part also. And further also, you people are in class 11, you will go in class 12, there also you will not have mechanics as a separate branch, but different branches, electromagnetism will be there, that will involve in between. You'll be solving questions of charges and current and all. In between, you'll be needing work energy theorem. So just have the concept clear. That will be helpful for you. So whenever the question is prove work energy theorem, do this entire day. This is actually very simple. You can see v square, you just have to integrate v square, put the value of acceleration, put the value of velocity. That's it. One more thing, that percentage change in momentum. See, kinetic energy has one more formula which I want to discuss with you. Kinetic energy is not just half mv square. Kinetic energy is p square by 2m, where p is the momentum. And m is, as usual, mass. So kinetic energy. Now, when we have to find out, there are certain questions which involve momentum changes like this way, calculate the percentage change in kinetic energy, momentum will change like this, calculate this. If the question is related to momentum and percentage change in kinetic energy, I'll make you practice this question, because this question comes a lot in your exams. Not even just for your class 11th regular school board exams. In your entrances also, those students who are preparing for NEET, JEE and the after class 12th assessment entrances, there also this kinetic question, energy question repeats itself. So nothing, what's the initial kinetic energy? You will find out the initial kinetic energy as P1 square by 2m. You will find the second final kinetic, this is K1, this is K2, as P square, P2 square by 2m. And how do you calculate the percentage change? Your mathematics, which you have studied till your class 10. P2 becomes P1 plus, suppose in this question it is 10% of initial momentum. So 10% of P1. And how do we calculate the percentage change in the kinetic energy? This is K2. How do you calculate the percentage change? Final minus initial divided by initial. So final is KE2 minus initial is KE1. What is original? KE1. And for percentage sign, we multiply it with 100. This won't be clear just now. We'll practice one question that will only be helpful. But from here, start noting it down. Wherever you're not understood, ask me, get it clarified.
Ma'am, can you scroll up? Done, ma'am.
Ma'am, can you go up?
Ma'am, how did the limits change to V2 and V1?
See, we were able to change the limits from V2 to V1. Actually, the limits are from V1 to V2 only because we want the change in velocity. But because of the formula is f dot dx, so it's from x1 to x2. But now we have eliminated dx. Now your formula is v dv. So when it's dv, you cannot have x in the limits. That violates the rules of integration. You have to have the same physical quantity. So that's why, because we wanted velocity. So we have done these modifications and have brought velocity in here. As soon as velocity came, the limits also became the limits of velocity. Clear?
Yes, ma'am.
Ma'am, can you go up?
Ma'am, what would be the percent change in kinetic energy?
Percentage change in kinetic energy you have to find out. You have to calculate. 10% is there, no? So this will be, this is P1 plus 10 by 100 of P1, right? 1 by 10. This is how you will find out the value of P1. So substitute in here. P1 is already here. Substitute the value of P2 in terms of P1 using this equation. Right, that becomes, this is 11.1 P1, no? This will become. So substitute this as 1.1 P1. So when you will put in here, P1 will be common from here, P1 will be here, that will get cancelled. So you'll get the percentage change. See, rest of the things will get cancelled, no? Even if you take this as an example, see, this becomes 10 plus 1. This is 10 P1 plus P1 divided by 10. That becomes 11 P1 by 10, which is 1.1 P1. So what do we have? We have P2 equal to 1.1 P1. So in this equation, we'll have this as 1.1 P1 whole square by 2m. 1.1 whole square will be what? This will be 1.21, right? So 1.21 P1 you will have 1 minus from here K2 minus K1, that is this minus this. So you can already take common P1 square by 2n. You can take it common. What are you left with? You are left with 1.1 square minus 1 square divided by kinetic energy 1. This is also P1 square by 2m. So this part gets cancelled, this part gets cancelled. This is your answer. So that will be 12% something change. Clear?
Ma'am, the value of P1 is 1.
Value of P1 is not 1. See. Let me get this. Wait. See, kinetic energy 1 is P1 square by 2m. P2 will be what? We do not know our P2. So this becomes P1 plus 10 by 100 of P1. That is 110 P1 divided by 100. So 1.1 P1. First tell me, P2 is equal to 1.1 P1. This is clear?
Yes, ma'am.
Okay. Now kinetic energy 1 is what? Kinetic energy 1 is P1 square divided by 2m. What is kinetic energy 2? That is P2 square. So 1.1 P1 square divided by 2m. Yes? So
Yes.
1.1 P1 square, this becomes 1.21. 100, yes, 1.21 P1 square divided by 2m. Now, what is the formula of kinetic energy? I have told you K2 minus K1. What is K2 now? P2, instead of P2, we'll have, what is K2 now? 1.21 P1 square by 2m. Yes, K2 minus what is K1? P1 square by 2m. So final K2 minus initial divided by initial K1. This is how you calculate percentage change, your normal formula where if any quantity is given. This is not just limited to the kinetic energy. So this is P1 square divided by 2m into 100, right? Till here, is it clear?
Yes, ma'am.
Okay. Now see, I can take P1 square common from here. P1 square by 2m common.
Yes, ma'am.
So P1 square by 2m I have taken common. I am left with 1.21 minus 1 divided by, what have I kept here? P1 square by 2. This cancels, this cancels. What am I left with? 1.1 minus 1, that is 0.21 into 100 for percentage change. So percentage change is 21%. Now clear?
Yes, ma'am. Ma'am, can you scroll a bit up?
See, this question says a bullet weighing 10 gram is fired with velocity of 800 meter per second after passing through a wall 1 meter thick. Its velocity decreases to 100 meters. You have to find out the change in kinetic energy. Means a bullet is fired with velocity 800 meter per second. This is the initial velocity, 800 meter per second. Then it crosses a wall which is 1 meter thick, pierces it, and when it comes out, the final velocity becomes 100 meter per second. We have to find out the change in kinetic energy. Change in kinetic energy is not difficult. See, initial kinetic energy is half mv1 square. What is final kinetic energy? Half mv final square, right? Let me make this as initial. So change in kinetic energy will be half m v final minus v final square minus v initial square. So let's put in the values. Half mass is given 10 grams. So we have to convert 10 grams. So that becomes 10 into 10 to the power minus 3 kg. Final velocity decreases 100 square minus initial was 800 square. So once you solve, this becomes 10 to the power minus 2, 1 by 200. This is 1 by 10 to the power minus 2. This is minus 64, 1, 2, 3. So when you solve this, your answer will be minus 315 joules. Kinetic energy, you're getting it as minus 315 joules. This will be 1 by 200. No, just cross check one. This is minus 315. Now, your kinetic energy, this is a scalar quantity. Grams into kg, because gram is the CGS unit and kg is the SI unit. So you have to convert grams into kg. All right. 1 kg is 10 to the power 3 grams. So in any ways, minus sign is just telling you that velocity is decreasing. Otherwise, kinetic energy, it's a scalar quantity. You don't need this minus and plus sign. These are not telling you the direction. Second part is saying what? Work done by resistive force. Work done is very easy because you don't have to calculate anything now. Work done according to work energy theorem. Work done is change in kinetic energy. So this is also minus 315 joules. Why is this minus sign? Again, this is not that minus sign which we use in velocity or the sign conventions which we were putting, that minus sign is indicating left or right direction. This is just telling you that velocity is decreasing. Even if you forget this minus sign, just put a modulus and write which is equal to 315 joules. Because it is no work done by resistive force. That's why it is coming negative. The opposing force, the resistive force, which is providing resistance. When the bullet is moving across the wall, there is certain resistance that is occurring in the wall. That is why negative sign we are putting it. And this is not telling you any direction. Work done is a scalar quantity. Average resistive force now we have to find out. See, work done is equal to force into displacement. How much displacement has occurred? It has covered 1 meter, right? Work done is also 315. So force is very easy. Force is work done divided by displacement. Work done is 315. Displacement is 1. So force becomes 315 meters. This is what? This is the average resistive force that is occurred. So kinetic change in kinetic energy, same thing as work done. Using work done and displacement, you have average resistive force. That's why the thickness was given. Note down this question, then we'll see types of work done. Question you people have written? Anyone wants to write down the question?
Yes, from just 1 minute. Done, ma'am. Ma'am, only when they provide us with an angle we use cos theta, right? With the formula f cos theta.
See, actually here also, no, not only when angle is provided, because the formula is f dot s. So how can you violate? You have to use fs cos theta, right? Actually, here the case is angle work done is what? Our work done is actually coming minus 315 according to the calculations. Now see, displacement, the bullet is displacing, is getting displaced towards this side. Now the resistive force, this will resist, no, this will provide resistance in the opposite direction. So displacement is occurring here, resistive force is occurring here. So theta is actually 180 degree. All right. So when you substitute minus 315 is equal to f, s is already 1, cos 80 degrees minus 1. This minus sign will get cancelled. So that becomes 300. So angle we in any case put. So since these were getting cancelled, that's why I straight away wrote it like this. But this is actual calculation. This also everyone noted down. Theta will be there. Clear?
Yes, ma'am.
Done?
Yes, ma'am.
Now the types of work done. See, depending upon the angle, we'll get different types of work done. Like if we have first type of work done is a positive work done. Positive work done means direction of force and displacement. They are coming in the same direction. This means what? Your cos theta is positive. That is acute angle. Acute angle means which is less than 90 degree. So you will have an acute angle. So once you will substitute this, work done is equal to Fs cos theta, your Fs will also come out to be positive. So in finally, you will have the work done as positive. That is what is meant by your positive work done. Whenever both the things are acting in the same direction or 30-degree angle is being made, 45-degree these angle. All right. Nextly, you have negative work done. Negative work done when theta is negative. Like in this case, see the example which we did. We had 180-degree as the angle. So automatically work done was already minus 350. Let's go reverse. Let's say we knew the force is 315. Displacement is 1 meters. So if angle is 180-degree, when you substitute it in the formula, you will get the work done as minus 315. So negative work done, it will all automatically come. So obtuse angle means actually it's in between 180-degree, the angle, but this is more than 90 degree. More than 90, less than 180 degree. That is your obtuse angle. So work done will
So
also.
if it's perpendicular, it will come as positive only.
For perpendicular, see. For perpendicular, what is the value? Of course,
90.
90 degree. That is value. Cos 90, 0. So you have a third type of work done. That is zero work. So zero work done, if exactly you're having theta is 90 degree, you get zero work done. This means force is acting perpendicular to displacement. You are getting zero work done. Second is when your displacement is 0. Suppose a body has started from this point and came back to this point. Displacement that occurred is 0. So work done will also come out to be 0. That is your 0 work done. So these are the basic types of work done. It's just that in certain questions, these will be mentioned. No doubts.
So, ma'am, in circular motion, the displacement is always going to be 0.
Not always. Whenever initial and final points are same, then only. It can happen half a circle is covered, right? Or a full circle and a half circle is covered. If displacement is coming 0, the concept of displacement which we have studied in the earlier lesson, then it will be 0 in any case. If displacement is 0, you cannot help, that is 0. If force is 0, work then will be 0. Or if force, displacement, they are present but angle is 90 degree, then also 0. Circular motion, if the entire complete circle has been covered, that's the condition. If it is a quarter of a circle, semicircle, 3/4 of a circle, that won't be 0. Here,
Ma'am, if the initial and final points are same, then the angular
then
displacement will be 0 also?
no, angular displacement won't be 0. Angular displacement will be 2 pi. Entire angle that has been swept. So that will be 2 pi. That is 360 degree.
Okay.
Okay. This is for linear displacement. Yes, the concept of conservative forces. Let's discuss this. This is very important. Important for your theory part. This is used. See, conservative forces are those forces which just depend upon the initial and final point. They do not depend upon the path that has been traveled. Suppose if I tell you this is a point A. This is a point B. You have A point, you have B point. This is one method of going from one A to B. There is work done in going from A to B. This path can also be obtained from going to A to B. There is work done from A to B. This is also a method by which you can go. So there is work done from A to B. When we talk about conservative forces, all these work done will be same. That is work done. If this is 1, this is 2, this is 3. So work done 1 is equal to work done 2, which is equal to work done 3. Now, if it is independent of the path traveled, then what it is depending upon? It only depends upon your initial and final position. These are your conservative forces, like gravitational force you have, electric force you have. These are all conservative forces. Gravitational force, electric forces, elastic forces. Whenever you are talking about electric force, one charge is present, another charge is present. In between, the force that acts, electric force acts. This is a conservative force. Then you will, gravitation is there in this class only, 11th standard. M1 mass is there, M2 masses are there. F is equal to M1 mkg M1 M2 by R square. So now this gravitational force, this becomes a conservative force. And remember, work done by conservative force is 0. If a path is closed, then work done by conservative force is 0. That's why we are studying. For this particular point, no, we have studied this. Potential energy is valid only for conservative forces. For non-conservative, you have no concept of potential energy. Kinetic energy is there for non-conservative forces also. Non-conservative forces are what? Non-conservative forces are those forces which depend upon the path traveled also. Whatever is the path traveled, they depend upon that, however it is crossed. Like frictional forces, viscous forces, all the dissipative forces in your nature. If this is the initial point, this is the final point. This work done and this work done 1 and 2. Work done 1 will not be equal to work done 2. Why? These are forces like your frictional force. Friction you people have studied. This is a dissipative force. All these forces which are dissipative force. You have a lesson, properties of fluids. There you get the concept of viscous force. Viscous force is just like frictional force, but in liquid, in fluids. So viscous force, friction force, these all depend upon the path travel. So they are non-conservative forces. It's just that why are we studying this? Because term will be used for conservative forces, for non-conservative forces. That's why we are studying it. Note down this as well. This completes with kinetic energy. Now we are left with potential energy.
Ma'am, closed path means the initial and final point are the same.
Yes, closed path means when the initial and final point are same. The entire path has to be closed. We'll continue the rest of potential energy. We'll start in the next class. So all those who have completed till here, you people can start leaving one by one. Okay, thank you so much.
Thank you, ma'am.
Ma'am, there's no after class assessment, right?
No, not today.
Okay, thank you, ma'am.